Good morning. All right, my advice for you on this is to turn to page 56, 57, and 58, do the problems, and then watch the video. All right, so if you haven't done these problems yet, go ahead and push pause on the video, do the problems first, and then come back. All right, so what we're going to take a look at today is just a connection between graph to table to equation, and so forth. So I want to address a lot of these arrows. And in fact, that's your goal for the unit test that's due on Friday. All right, so let's go ahead and take a look at some of the selected problems. I'm not going to do them all, but I want to look at some of the selected problems. So our first goal is to write a situation based on either a graph, an equation, or a table. I think this one's the one that's a little bit more difficult than the other two. So let's take a look at A. All right, so in part A, I have some information right away. I know that I start with 16,000, and let's make this dollars. They never said anything. I'm going to create my own situation. So I have $16,000, and I'm going to make a table. Tables are my go-to. So at time zero, year zero, I have $16,000. At year one, I have 14,000. All right, so now I kind of can start a story. I can say, hey, at the start, I have $16,000. The first year after, I have $14,000. How much do you think I'll have in year two? Well, before I figure that out, I have to find the multiplier. So I need to know what I'm multiplying by. So what am I going to put in my calculator to figure that out? Yeah, hopefully you said R equals 14,000 divided by 16,000, and I can stick that into my calculator. Notice I put 14 divided by, oh, actually I didn't. I put 14 divided by 16, which is 0.875, because the zeros don't matter, right? They can cancel each other out. So I got 0.875. So to get the next number, 14,000 times 0.875 is 12,250. So from here, I can get an equation. So y equals, and you're probably wondering, why am I doing this? Because now I'm going to be able to tell my story. The equation helps me tell my story. So I can say, when I started retirement, I had $16,000. Each year, I spent, how much did I spend? 87.5% was remaining, but how much did I spend each year? Well, remember, you can take 100 minus 87.5, and we could do that on our calculator. So I'm spending 12.5%, right? We started 100, and if I end up at 0.875, I'm spending 12.5%. So that's part of my story. I start out with $16,000, and I spend 12.5% of my retirement each year. All right, let's take a look at the next page. This is a fishing lake, and this is just to word it a little bit tricky. So currently there are 1,800 trout in the lake, and it's been determined that the rate of death is 1/3. So 1/3 of the fish will die. So how much of the fish will be alive? Well, if 1/3's dead, 2/3 must be alive. So sketch a graph showing how many fish are left in Leticia's lake over the next several weeks. All right, so then we have weeks, and I have a hard time doing a graph unless I have some key information, so that's what I'm going to get. So we're going to go, how many fish are alive? And that's what they're calling how much is left. Well, they start out with 1,800. So now I have X is the weeks, and this is alive. And then after the first week, 2/3 are remaining. So that's my multiplier. So I'm going to have 1,800 times 2/3. So that's 1,200. And then I can continue, right? So this is multiplying by 2/3. So after week one, I guess I should break this up kind of a little bit more evenly. So if this were 2,000, this would be 1,000. So 500 would be here, and 1,500 would be here. So 1,200 looks like it falls right about here, right? And I know it's going to be exponential. So I can continue that. So there's my graph. And then theoretically, will the fish ever disappear? If I continue this table, will I always have a number? Yeah, I will, because we have an asymptote here. Realistically, eventually you can't have half a fish, because once you get to a certain point, you're going to be like a half, a fourth, a 16th, and so forth. That's not exactly true because we're talking about 2/3. But you get the idea that this is never going to go below my x-axis. All right, number 79, going from a graph to an equation, and we've already done a little bit of that. In order to get a graph to an equation, what I need to do is have some sort of a table. So day 0, I have 7,000 fish. On day 1, I have 7,700 fish. So if I want to get the multiplier, again, I'm going to take 7,700 divided by 7,000. That's 1.1. So there's my equation. My starting value times 1.1 to the x. All I did to get that is take 7,700 divided by 7,000. That was my multiplier. So in the first year, it was 7,000. The cost in 2,000, they're going backwards. So if I want to make a prediction, I want to use my equation. What do you think I'm going to put in for x? Well, if it was 10 years ago, it's going to be -10. So I could just put that directly into my calculator. And again, you could put this right into the Google bar and it will give you an answer. Just put parentheses in the right place. Well, I put 11. It's 1.1. There we go. So that's 2,000. $698.80. Right, so 10 years ago, that's what it would have cost, according to our model. Right? And then you could actually figure out the rest. But I wanted to kind of deal with when we make predictions, this is a big idea in our class. When you make a prediction, we're going to use our model to make our prediction. All right, flip it over. Going from an equation to a graph. So I want us to be pretty quick with these, right? We have a starting point, and this tells me that it's increasing. We have a starting point, and it tells me that it's decreasing, because that's between 0 and 1. We have a starting point, and this tells me that it's increasing. That's what I'm looking for. Cool? All right. And now we have different situations. So again, I'm only going to pick one of them, and I'll let you take a look at the rest. So the math club is fast becoming one of the most popular clubs. Okay, each year, the club enrollment increases by 30%. If the club has 45 members, right, that's my start. How many members should expect to have in 5 years? There's my prediction, and it's increasing by 30%. So when I do a percent increase, I go from 100% and I go up 30%. So that's going to be 130%. That as a multiplier is 1.3. And we've done that in class. So now I need to make my prediction. That's kind of the gist on how you do all of these. All right. All right. I'm going to go ahead and let you finish the rest. If you have any questions, please let me know.